Alright, so for rational functions, when they ask for the domain, we need to look at the denominator. So we are looking for values that make the denominator 0. So I'm going to factor out an x, and then that leaves me with a quadratic that I'm going to test to see right now if it factors. So I get negative 18 when I multiply those together. Factors of negative 18 that add up to negative 7, negative 9, and 2. And then factor any method you like. I always like the box, but choose whichever one works for you. Greatest common factor is 3. 2 times 3 is 6. Negative 3 times 3 is negative 9. 2 times 1 is 1. And I check that 1 times negative 3 is negative 3. That works. So that tells me that the denominator is x times 2x minus 3 times 3x plus 1. That's a denominator. So that means that the domain is all x such that x cannot equal 0, 3/2, or negative 1/3. Okay. Now for wholes, no common factor in the numerator and denominator, because I've got x to the fourth plus, not x to the fourth, sorry, x squared, let me fix that real quick, plus 4, which doesn't factor, and I have these, none of these are x squared plus 4, so that means that there are no wholes. X-intercept, you look at the numerator, whatever makes the numerator 0, and no real number does that, so there are no x-intercepts. Y-intercept, well, right off the bat you see here that x cannot be 0, so that means that it has no y-intercept, because when you cover up the x's, you end up with 4 over 0, which is undefined, so there's none. Vertical asymptote, you look at the domain, which is a denominator, so I have x equals 0, x equals 3/2, and because none of these in the domain became wholes, then they are at a vertical asymptote. And this is a bottom heavy rational function, because this 3 is bigger than the 2. So then that means it has a horizontal asymptote of y equals 0. Even though the top is even, the bottom is neither, so the whole function itself is no symmetry. So none. So now we're going to get ready to graph. Alright, so I set up my x and y axis. Notice how I numbered, they're numbered differently, the x and y, but within the axis they're numbered like it's the tick marks are evenly spaced out, and I'm going by the same interval. So that's okay as long as you stay consistent within the interval, within the axis. So across the x-axis I'm counting every tick mark as 1, but I'm skipping a grid line. And on the y-axis every tick mark is 3. Okay, so as long as you're consistent, it should be fine. So first thing we're going to do is draw the asymptotes. So vertical asymptote is x equals 0, so that just goes right over this y-axis right here. And then we have x equals 3/2, that's 1.5. So that would go here, 1.5. And then negative 1/3 is a little bit trickier, so it's going to be about here. It's just approximate, and it's really tight right there. That's about negative 1/3. Okay, and then the horizontal at y equals 0. Notice I have no points because there were no holes, no x-intercepts, no y-intercepts. So I'm going to have to do do some calculations. So I'm going to do f of negative 1, and that goes into the original function. So negative 1 squared plus 4 is 5. And when I put a negative 1 in the denominator, I end up with a negative number. So it's going to be negative 6 minus 7 plus 3. So that's negative 10. So f of negative 1 is negative 1/2. So negative 1, it's going to be negative 1/2. Really close to the axis because of the way I numbered the y-axis. But that's all I need to graph my curve right here. Now I'm going to try f of 2. F of 2 squared is 4. 4 plus 4 is 8. If I put a 1 in the denominator, I'm going to end up with a positive number. Right? 6. I'm sorry, with a 2, not a 1. That's going to be 48. It's going to be a positive number. So an 8 over a positive is positive. So when I sketch this, it's going to go something like this. Because I know it's above the x-axis because it's positive. Then I'm going to put in f of 1 because I want to see what happens in here. I want to see what happens in this section. So I'm going to put in f of 1. So 1 plus 4 is 5. And then if I put a 1 in the denominator, I get 6 minus 7 minus 3. That's going to give me negative 4. So that's going to be negative 1 and 1/4. So about here. And so from there, I know it has to go down towards the right asymptote and then down towards the left asymptote like that. And my last thing is I need something in the small section right here. I need to see where to graph, the curve here. So I'm going to try a number between 0 and negative 1/3. So I'll try f of negative 1/4. Now I plugged this into the calculator and I got 18.4. I used negative 2.25. So I put it in as a decimal. So I get about 18.4. Well, that means that up here, it's going to go somewhere up here. And it goes, it's really skinny curve. Okay. It actually, the lowest point I think actually is negative 14 point something. I plugged it into a graphing calculator. But since you guys aren't going to have one, if you do this work, it's enough. I mean, I won't dock you if your graph is inaccurate like here or here, because you need a graphing calculator for that. This is good. This would give you full credit. Alright, so I'm going to factor the both numerator denominator. So I multiply 9x squared minus 2, and that gives me negative 18x squared. Factors of negative 18 that add up to negative 3 would be negative 6 times 3. Excuse me. I'm going to use that for the little box. 9, 2, negative. Again, you guys can factor any way you like, whatever works for you. It's a multiplication, so this is 3, negative 2, and 1. And that works. So the numerator is 3x minus 2 times 3x plus 1. The denominator I could factor out a 2, and then I have difference of squares, because when I factor out a 2, let me show you here in the bottom, I get 9x squared minus 1. So this is difference of squares, 3x minus 1 and 3x plus 1. Okay? So for the domain, remember we look at the denominator. So x such that x cannot equal 1/3 or negative 1/3. For the holes, this one actually does have a hole because this is a common factor top and bottom. It's at negative 1/3. And you replace the x, so this is gone now. Replace the x's with negative 1/3, so I get, in the numerator, I get 3 times negative 1/3, which is negative 1 minus 2. In the denominator, I get 3 times negative 1/3 is negative 1 minus 1. So that's negative 3 over, this is negative 2. So -4, so I get 3/4. X-intercept, the numerator cannot be, or what makes it 0 would be 2/3. Y-intercept, you just cover up all the x's and you have -2 over -2 in the original function. So that gives you 0, 1. For the vertical asymptote, you look at the domain. Now, in the domain, x cannot be 1/3 or -1/3, but the -1/3 became a whole. So the only one left is this one. So that's your vertical asymptote, x equals 1/3. This one is a powers equal, so you look at the leading coefficients, 9 and 18, so you get y equals 1/2. Now the top is neither, so the whole function is neither, so none, no symmetry. Okay, so the asymptotes go first, so x equals 1/3. Again, approximating it, it would be about here. It's kind of crooked, but it's about here. And the horizontal would be y equals 1/2, would be here. Okay, then I have a whole at -1/3, 3/4, so that would be about here. And then a point, the y-intercept at 0, 1, and the x-intercept at 2/3, 0. So that would be about here. And that's all you need. The one on the x-intercept, that's your anchor for the bottom branch. And then the whole and the y-intercept are your anchors for the top branch. And that's it.